Okay, today we're going to be looking at the length of an arc. When we're looking at the length of an arc and dealing with radians, we actually find we have something that looks a lot simpler. So let's consider some circle with centre 0, and we've got the sector here, and we want to find the length between A and B. And we've got some angle theta in radians. Now, from our definition of a radian, the length AB will be equal to r times theta. So the arc length equals r theta. So let's look at a few wee examples of this. An arc subtends an angle of pi over 3 radians at the centre of a circle with radius r equal to 15 centimetres. Find the arc length. And we'll find it in terms of pi. So A equals r theta, we know the radius is 15, times pi over 3. These will cancel out, so that will be 5 up there, so that's going to be 5 pi centimetres. Now we've got a sector with angle 1.5 radians, and the arc length is equal to 12 centimetres. Find the radius. So we know that A equals r times theta, the arc length is 12, the radius is something that we don't know, theta is 1.5, so r must be 8 centimetres. Really simple, nothing too complicated here. Now, I'm going to look at something that is a bit more tricky that we have to think about. We have a triangle, and we're going to call the triangle ABC, and it's an isosceles triangle. With AC equal to CB, and that equals 8 centimetres. Now CD is an arc of a circle with centre B and angle ABC is equal to 0.9 radians. So let's find out what does this look like. So this is what this isosceles triangle looks like. So these two, this is A, B, C, and this is 8 centimetres, this is 8 centimetres. And we have an arc here, and this angle is 0.9 radians, and this is point D. So firstly, we want to find the length of the arc CD. So this is quite simple, because we know the angle and we know this is the radius of this circle. So the arc length is going to be equal to r theta. So that's 8 times 0.9, which is 7.2 centimetres. Now, I want to find the length of AD. So this is this length here. Now, let's think about this. Now, I've not actually drawn this very well. So we're going to have a line down here. And this is at right angles. If this is 8 and this is 8, this is a right angle triangle. And so 8, and they must be equal because it's an isosceles triangle. So if you think about, I'll just draw the isosceles triangle. If we drop this, both sides of the triangle are symmetrical. So we're going to use the cosine rule to find BD. BD must be equal to the hypotenuse, which is 8, times the cosine of 0.9. But because these are equal, the whole of BAB must equal to 2 times BD. So 2 times 8 times the cosine of 0.9, which is 9.95. So AD must be equal to 0.95 minus 8, because D is part of the circle of radius 8. It's badly drawn, I'm sorry. Which makes it 1.95 centimetres. So this bit here, AD, is 1.95 centimetres. Now, what we're going to do here is colour this wee bit in. And we want to find the perimeter of the shaded bit. So that's going to be equal to AD plus DC plus AC. AD is what we've just found, 1.95. DC is the arc length, which we've found up here, which is 7.2, and we know AC is 8. So that means the perimeter must be 17.1 centimetres. So I hope that helps.